Random variables and probability. A random variable is a function defined on a sample space that consists of real values. They are used to model unknown quantities in statistical analyses by mapping the outcomes of a random experiment to numbers. In other words, the outcomes are being assigned to numbers. The random variable r is defined as 1 if it's raining outside and 0 if it's not raining outside. Here's another example. The random variable a is defined as the sum of the upward face of two dice after they are rolled. So here is what a looks like. How could defining random variables be useful? If we were asked to calculate the probability that the sum of two dice is equal to 7, it can be written as the probability of a equals 7, instead of the probability of sum of upward face of two dice after they are rolled is 7. Random variables are not the same as traditional variables, e.g. x plus 3 equals 5 yields x equals 2. Random variables can take on infinite values instead of just one. They also result in different probabilities. For example, the probability of a equals 7 is shown on the last slide. Other probabilities could also be found, such as the probability of a equals 11, the probability of a equals 3, etc. Discrete random variables are random variables that take on distinct, separate values. These values are generally countable. So here's an example. Outcomes when rolling a six-sided die. B is 1, 2, 3, 4, 5, 6. Continuous random variables are random variables that can take on any value within a range or an interval. These values are generally infinite, i.e. not countable. So numbers contained in the set of integers would include -3, -2, -1, 0, 1, 2, 3, and so on. The random variable r is defined as 1 if it's raining outside, 0 if it's not raining outside. Is r discrete or continuous? Explain. The random variable t is defined as the exact amount of time it takes for any object to fall to the ground. Is t discrete or continuous? Explain. In this example, it's discrete. The outcomes are distinct, separate values. One can count the number of values that the variable can represent. In this example, t is continuous. The object could be anything, e.g. a feather, a book, a spoon, etc. Therefore, there are an infinite amount of values that the variable can be assigned.